Hello everyone, I am Shubham Desai and I am here with an interesting article on Hyperloop. As we all know that transportation plays a key role in development of mankind. But what if in case of emergencies we are not able to transport humans or goods faster? So here's the way to transport anything faster as wind, ironically in absence of air. Have you ever wondered transportation other than vehicles, trains, airplanes, ships? Yes, the fifth mode of transportation, the Hyperloop. What is an Hyperloop? Hyperloop is a network of sealed tubes with extremely low air pressure which carries a floating pod or a capsule in it, which travels substantially free of air resistance. It can travel at a whooping speed of 700 miles per hour, that is 1126 km per hour. The concept of Hyperloop was invented and first introduced in 1812 by the British mechanical engineer George Wenger, but a resurgence in interest was observed in this concept when it was reintroduced with updated technologies and design by Elon Musk after 2012. What are the components used to build the Hyperloop? Well, it has a tube made up of steel and has an air pressure of only 100 Pascal, which is 0.001% of atmospheric pressure. It has a sealed capsule with a capacity of carrying 28 passengers that travel along the interior of the tube. The capsule is supported via air bearings that operates using a compressed air reservoir and aerodynamic lift. For linear accelerations of capsule along the length of the tube, stator is mounted on the inner bottom of the tube and rotor on the bottom of capsule, which functions exactly like a motor. It also has an air compressor in front of capsule which compresses air with a pressure ratio of 20:1. Some air is stored for passengers and air bearings. How does it work? It has a simple working principle same as of air hockey. The pods would accelerate to cruising speed gradually using a linear electric motor and glide above their track using passive magnetic levitation or air bearings. It is levitated and propelled forward using powerful electromagnets, which has a powerful electric supply. This itself considerably reduces losses due to friction, as the train is literally gliding over the track and is not in contact with the track. Hence, there are no frictional losses, allowing the train to move at higher velocities. The absence of air in the Hyperloop will further increase the efficiency by nearly eliminating losses due to air drag and make it much faster. The capsules are supported on a cushion of air featuring pressurized air and aerodynamic lift. The capsules are accelerated via a magnetic linear accelerator affixed at various stations on the low pressure tube with rotors contained in each capsule. Residual air in the tube is captured, compressed, and forced through holes in skis attached to the bottom of the capsule. The gap between the skis and the tube during operation is between 0.5 mm and 1.3 mm. The air pressure in the tube is very low. A capsule traveling at 700 miles per hour will cause significant air pressure at the nose of the vehicle, which must be considered in the design. Since the tube has a larger cross section than the capsule, some air flows around the vehicle. Even so, compressor fans that actively transfer air from the front to the rear of the capsule must be installed. Ongoing Hyperloop projects in India. First project is in Andhra Pradesh, which connects the city centers of Amravati and Vijayawada, which has a distance of 35 km and will be covered in 5 minutes through Hyperloop. Second project is in Maharashtra, that is from Mumbai to Pune, and estimated travel time is 25 minutes. Third project connects Bangalore airport to the city in Karnataka. Well, as the Hyperloop is faster, cheaper, pollution-free, and is also resistant to earthquakes, no doubt it will be the most preferred and reliable way for transportation in the future.